Today I want to tell you about the main project I work on here, which is building a telescope. The telescope flies on a balloon, and I think that's pretty interesting because it's a very unique telescope. So the thing we want to study with this telescope are regions in the galaxy that look a lot like this. This is an image usually called the pillars of creation because it shows these large dust pillars that are forming many, many stars. The problem with this image is we can't see inside the dust columns, we can only see the surface, and so you can't see the very youngest stars in the earliest stages of formation. So what I'd like to do is have a telescope that can peer inside and learn more about those earliest stars. Now, if I'm going to build a telescope, one of the first things I have to decide is where can I put it? One option, of course, is space. This is the Hubble Space Telescope, you may recognize it. But telescopes in space have a very high budget. The Hubble Space Telescope costs about $2.5 billion to make, whereas a telescope that flies on a balloon usually has a much lower budget, somewhere around $10 million. And that's about the budget of the telescope that I work on. So we can build, actually, for the budget of one Hubble, we could build about 250 balloon-borne telescopes. This is a picture of the telescope I work on called BLAST. This was a picture of it a few years ago when it was in Antarctica, right before launch. You notice the size, it's actually pretty large. The people at the bottom are much smaller than it. It probably would go all the way up to the ceiling if it were in this room. And right after launch, it looks more like this. So you notice that the whole structure on the left is very small at the bottom of the image on the right. And so the balloon that carries this telescope up is also enormous. The balloon, as it rises through the atmosphere, actually swells to about the size of a football stadium, and it stops rising when it gets to about 100,000 feet, which is 2 to 3 times higher than a plane that you might take. And the view up there looks about like this. This is a picture taken on another balloon-borne telescope. As you can see, you're above most of the atmosphere. The number is about 99% of the atmosphere is below the balloon. So you get really great views of space that you could never get from the ground because all the atmosphere is in the way when you're on the ground. You may have noticed that all the pictures I've shown you of these telescopes so far have a lot of snow around. And that's because we take these telescopes to Antarctica. You might wonder, well, there's atmosphere everywhere. You can fly a balloon everywhere. Why would you bother to take it all the way down to Antarctica? The first reason for that is this. This is a visualization of the winds in Antarctica. You can see that they kind of form a large circular pattern around the whole continent. This means when the balloon goes up, it stays above the continent because it just follows these winds. And that's really nice because at the end of the flight, after about a month of staying up in the air, we have to disconnect the telescope from the balloon and it comes back down on a parachute. We want it to land on Earth, not in the water. So Antarctica is convenient for that. It's also nice that Antarctica has a very low population, so it's not, we don't have to worry about the balloon falling on anyone. And this is the path that our telescope actually took about 5 years ago. So it's been about 10 days traveling around Antarctica and then came back down and we collected it. This next time when we go, we're hoping that the telescope will stay up for a whole month. The whole timeline of getting a telescope to Antarctica starts years ahead of time. We spend several years building the telescope. This picture was taken only a couple weeks ago in our lab in Philadelphia, where we just put the big red part of the telescope, which houses the telescope's camera, into the supporting structure of the telescope, and it all fits, which is great. So it's all coming together. The plan is in August, we will ship the telescope in pieces down to Antarctica, and then we will follow it down there in November. We will spend about a month in Antarctica putting it together and testing it to be sure it all still works, and then launch it in December. And then it again stays up for about a month, as long as everything goes correctly. And then we cut it down and it falls on it with a parachute, and then we go collect the data. We'll spend several years looking at the data, publishing papers on it. I want to take a look at what the data actually looks like, but first I'm going to show you, this is a picture of the Earth and its magnetic field. The important thing to notice here is the Earth's magnetic field. Well, in the magnetic field of the Earth, compasses always point along the magnetic field. That's why compasses always point toward north. So that's I just want to explain what magnetic field lines kind of mean. This is a picture like what we would take with our telescope. So the colors here are showing where there's a lot of material and where that material is bright and forming stars. So the darker regions that are kind of red are very bright, and the blue regions are very dim. And the wavy pattern across the picture actually shows where the magnetic field is. And when we study pictures like this, we can learn what the magnetic field actually does to influence how the stars form. One thing it can do is it kind of acts like a big spring and keeps the clouds from collapsing and actually forming those stars. And as the stars form, when they get onto later stages, most stars will form disks, and those disks can eventually form planets. But sometimes magnetic fields stop the planets from forming. And so if you want to understand where planets come from in our galaxy and where we might have a good chance of finding life other places in the galaxy, you really need to understand these early stages of what the magnetic fields do to form stars. So that's most of what I work on, just building telescopes, taking them to Antarctica. I think it's really fun because I get to point at a telescope and say that's the thing I actually built, and then we get to spend a lot of time analyzing the data and learn exciting things about the universe. So thank you.